Question says, in which of the following compounds iron has lowest oxidation state? In the given compounds, we have to find in which compound iron is present in its lowest oxidation state. Okay, let's calculate. You can see first option is what? This is a double salt. This is one salt is given here, and this is another salt, and this is what? Water molecule is here. Okay, for iron we can calculate oxidation state. Now pay attention carefully. Now you can see we have a FeSO4 dot ammonium sulfate. Okay, ammonium sulfate, and then dot 6H2 is there. Listen carefully. This is what sulfate ion is here. Sulfate ion. Sulfate ion always carry -2 charge. Okay, this salt is neutral salt. Neutral salt is there. If sulfate ion is -2, then iron will be present in +2. Very simple. This is a neutral compound. Then overall oxidation number of this neutral compound will be 0. Water molecule is also neutral. Then oxidation number, overall oxidation number of water molecule will also be 0, because if we add the total oxidation number of hydrogen as well as oxygen, it will be equal to 0, because it is a neutral molecule. Okay. So in this case, we can see iron is present in +2 oxidation numbers. Okay, you don't need to do complete calculation. Plug in the oxidation number of nitrogen, hydrogen, sulfur, oxygen. Otherwise, you will mess up. Okay, think in that way. One salt plus another salt plus 6 water molecule. Water molecule is a neutral molecule. 6 multiplied by 0. Okay, we can write like this. This is what Fe plus sulfate. Overall sulfate ion is what? -2, and plus this is a neutral molecule. We write 0 plus 6 multiplied by how many water molecules are there? 6. And each water molecule is a neutral molecule. Then we take it as 0 and is equal to 0. Now you simplify. We get Fe -2 is equal to 0, and it gives Fe is equal to present in +2 oxidation numbers. That's it. Okay. Now I go for the second one. In this case, we got iron is present in +2 oxidation numbers. Okay, second option is there. In the second option, it is a complex compound is given here. Okay, no problem. Let's calculate. We have K4. Okay, K4 is there, and Fe, and then this is what? Cn, and whole 6 is there. This is complex compound. This bracket is supposed to be there, and these kind of compounds you will study in coordination chemistry. Okay, potassium. First group elements present in any compound will always show +1 oxidation numbers. This is a neutral complex. We write is equal to 0. Okay. How many potassium are there? 4 potassium. Each potassium is what? +1. Okay. Then iron is there. We follow the same method. And how many cyanide ions are there? Each cyanide ion, like let's say if I mention this is what? HCN. Okay. HCN. Hydrogen cyanide is there. So if I remove one positive charge, then it will bear one negative charge. So Cn carry -1 charge. Okay. So 6 multiplied by what? -1 is there. Now we can simplify. +4 plus iron -6 is equal to 0. Then Fe is what? -2 is equal to 0. Then iron is present in +2 oxidation numbers. Okay. So in this case also we are getting iron present in +2 oxidation number. So there is no comparison exactly. Now we go for the option C. Okay. So in this case we have we can take we have Fe. This is what Fe is there, and CO whole 5 is there. Organometallic compound is there. This is a neutral molecule. Keep in mind, this is a carbon monoxide here. Carbonyl group it is given there. It is taken as a neutral ligand. Then we can say Fe plus 5 and CO is what? A neutral molecule multiplied by 0. Okay, and is equal to 0. Then Fe is equal to 0. Okay. So iron is present in 0 oxidation number in option C. Okay. Now if we talk about the D1, Fe2O is there. Okay. And in general it is supposed to be Fe2O3 actually. Okay. I mentioned Fe2O3 is there. So if you calculate oxidation number of iron, Fe2O3 is there. So you can crisscross this number. 3 will go left side, first one is +2, and 2 will go right side, and second one is -2. So iron is present in +3 oxidation numbers. Okay, that's it. Now you can compare. plus 2. In case of C option, it is present in 0 oxidation number, and D option is what? Plus 3 oxidation numbers. You can see option C is correct, in which iron is present in its lowest oxidation number. It shows 0 oxidation number in option C.